Good evening all. Am I audible? The slide is full screen. Can you able to view the full screen slide? Am I audible now? Hello, am I audible now?
Yes, sir.
Okay, so today we'll start the discussion about software design. So in the last class we have seen like how to gather the requirement and how to document it in the form of a software requirement specification. The next phase is the design phase. So in case of design phase, the main task is to convert the SRS document in the form which can be implemented, okay, through any programming language. Okay, so that is the next stage. Next step, we normally don't go by SRS to the coding. We first do a SRS documentation which specify what is required. Okay, and then we convert it into another documentation that is called design documentation. Design is very crucial stage or phase of software development. There are so many facts that you have to look into while designing your software. Okay, but obviously that whenever you go for a design should be irrespective of any programming language. Okay, you should not keep in mind usually any I mean uh, programming language. Yes, you can think about the programming paradigm, like what type of programming you're going to use it, whether you're going to use object-oriented programming or whether you're going to use non-object-oriented programming platform. So based on that only your design will move. And design, if your design is good, you can expect a better software at the end. And why design is important is as like any other construction or any other engineering activities, design is very important. If there is any flaw in the design, okay, then that will going to propagate into the actual item or that you are constructing, like building and all. If you're constructing any building, very uh, multi-story building and all, if there is any error in the design, then that the next step will go, and the next the stage people will going to follow exactly the design, whatever it has been instructed, without thinking much about what is the consequences, because the consequences and all everything that need to be taken care during the design. So say for a car manufacturing company, if they go for manufacturing car, so they have to keep in mind or they have to consider all the aspects of a car, like its speed, its balance, okay, its balance, its stability, equity, okay, its look, okay, its I mean comfort, the comfort, everything that need to be taken care during by the design team only. The implement whosoever is going to be part of that manufacturing the car will never going to look much about all the aspects. They just follow whatever it is there in the design document. So that is the thing that software also going to be the same thing that we need to follow. Design also should be very you have to do very carefully you have to do it. You have to think too many things, too many aspects, while uh, designing a software. Okay, now what is there in the design in case of what is called in case of other things that you can ask, we have mentioned so many other things, but here in this case, primarily we're going to see how the program will going to be uh, arranged in the form of a module. And what is modular structure? If I can remember earlier, we have discussed that for a large problem, we need to divide that problem into some modules, what we call it as a decomposition. Okay, decomposition of the problem. So how you are making the decomposition, that matters a lot. Okay, it should not be any kind of an arbitrary kind of uh, breaking up of the whole problem into sub problem. So that is the beauty of the design. I mean, we're going to see what are the characteristics which should be there while designing any software or while arranging, dividing. A software problem into some modules. Okay, so that is the main uh, task to be considered during design. Okay, so module and the relationship among the modules. Okay, what is the relationship with the modules? Module is what? Module is, I'll come into that. What is module exactly? It looks like module. We're going to see that thing. So and then there is always kind of a dependency is there among the different modules. Say you have a very large software problem and you have divided into 10 different modules. Okay, now these modules somewhere have certain level of dependencies among each other. Okay, they cannot work with the help of the other module. Okay, so this is this relationship of invoking those modules is also playing a very important role while designing. And and one module interacting with the other module during that interactions, how they are interacting with each other, what type of data they are passing from one module to the other module is these things also have to be shown in the design. Okay, and then of course whenever I go for the what is called uh, program implementations, we need two things. One is data structures, and at the same time some good algorithm or logic to implement that thing. So that also should be part of that module. Okay. So say you have a very large problem and you are dividing into some sub problems. Okay, sub problems. So M1 is the say M1 is the big problem, main problem, and then you are dividing into two sub problem M2 and M3. Again M2 M3 you are dividing into another three sub problem M4 M5 and M6. So what actually happens? M2, to complete M2, it needs the help from the module M4, M5 and M6. Similarly, to complete the whole task of M1, it needs the help from module M2 and M3. So you can proceed from there. If the arrangement is something like that, these subtasks are basically arranged in such a way such that they have a dependency. So M2 is dependent on M4, M5, and M6, and M1 is dependent on M2 and M3. Now module is what? Module you can think somewhat about your class, whatever you have studied during object-oriented programming, where you have data and you have a set of functions. Okay, that you can think of. That's why it's very easy to do modular programming using object-oriented programming, because object-oriented programming having that inbuilt facilities or features of modulations or modularizing the big problem. Now think about a particular module. Module is nothing but a set of functions which will be clubbed together and some data on which this function is going to act. Okay, so you can think about a class or object or class. You can say class in a object-oriented programming. Now, what is the main concern over there? Now, how you are basically clubbing those functions? Okay, there are a number of functions which may be there. Now, how you are segregating and clubbing together these functions in a single package, single box, a single class, whatever you can. That determines how good my design or how bad my design is. So that is the overall thing that we would like to we will see during this design chapter. So a module is basically consists of several functions and associated data structures. Okay. Uh, there are two levels of design. One is that is called high level design or preliminary level of design, where we just we try to I mean, design that what we call is architectural design that primarily on dividing them in some modules and what is the relationship between the modules. That is more preliminary design, and detailed design is somewhat more close to your programming language. Okay, the detailed design is more close to a programming language. So in that case, it's not exactly the programming, but detailed design is it's somewhat very close to the programming language that you're going to use it. Their structures, their syntax, some way, the pseudocode kind of thing. That detailed design is going to incorporate all those things so that it is easier for the coding team to implement those design. Now, as I mentioned, that high level design or preliminary design is basically to take the whole problem, analyze. I mean, though it's analysis and all, it's not required from the scratch, because in the SRS document itself, if you can remember correctly, we have already done certain level of modularization. Say, if you can remember the what is called library automation system, that there we have divided into some requirement or requirement 1, requirement 1.1, and then we have mentioned what is the input, what is the output, and what is the activities. Okay, say the read members details, then search the book followed by that particular member, and then another one is renewal of a particular book. Okay, so these are already subdivided in SRS program. Now we have to arrange in a proper way in terms of high level design. Okay, so say design one of the function is library, what is called library management system. So the library management system, you have renewal of the book, issuing of the book, calculating fine, new member entry, managing the member, like new member entry, deleting the member. So all those things are basically the submodules of a library, whole library management system. So M1 is the library management system, the whole software library management system, and then you have two submodules, say what is called renewal of books and issue of books. Say, just for the example, we are considering two. So M2 and M3 is for this. Now again, renewal of the book M2 can be divided into subtasks. So what is that? You read I mean, member ID. Then M5 may be display the details, and M6 may be the renewal of that. So the three M4, M5, M6, until unless they perform, you cannot come say that M2 is done. And once you have M2, I mean M1, until unless M2 is performing well, you cannot say the overall library management system, that is M1, is not going to work properly over here. Okay, so that is the whole thing, that SRS document already having some certain level of modular structures. Now you have to put it in the form of a nodes and edges, in the form of a I mean the modules and the relationship among the modules. So now what is that? Um, the what is whatever you are doing in case of high level design, that is basically called the software architecture. That means the organizations of different modules within the software and the relationship between them. That is what we called it as a software architecture, or you can say it's a program structure. Means how we are going to implement. M1 you have a different functions or something like that, or different modules and all that you can do it using from looking into that high level design. So whatever we have shown, the tree-like structure, that is called structure chart. Okay, so structure chart is there, and then there are some other notations are also available, which is called Jackson diagram or Warner Road diagram. These are very old methodologies. Still, people are using Jackson diagrams and all. I have not included any such example of Jackson diagram or Warner Road diagram. I'll show you. Only difference is how you are drawing these different symbols to represent modules, to represent dependencies and all. That's where the Jackson diagram or near road diagrams are very with the structure chart. But anyway, we'll show some example in the structure chart only. Okay. So now go for the detailed design. That's now these are more now close to the implementation. Okay, like what will be there? That what will be there in the inside the module, every module. So data structure. What are the data structure will be there? What are the functions or algorithms will be there within a module. Okay, and normally what happens in a software company, people divide these things into different modules, and then they create some small team. Okay, so small team, say team 1, team 2, team 3, team 4, like that, and those modules are normally assigned to some of the team. Okay, and they start doing these things parallel. And some project team lead. Okay, team leads are there. He relatively is senior than the programmers or the freshers programmer, and they basically controls a 2-3 team. And then the what is called team lead. Team lead will going to report. There may be one or two team lead, and team lead will going to report to the project manager. And finally, the project manager will going to look into what is called the overall progress of the software development. So here, the earlier the high level designs, the outcome is basically structure chart. Sorry, the software architecture or program structure. And then after details, then you are going to get the module specification. That means what will be there inside each and every module. Now, which one is? It's very obvious question is that, like, and you see, for a single problem, there may be, as I mentioned, for a single problem, I mean, there may be more than one number of solutions. It's possible. Okay, the more number of solution is possible. We have discussed these things, and accordingly, the more a number of designs also possible. Now we have to decide, or we have to go by which one is a good or bad design. Okay, which one is good or bad design. Okay, because it's very important. Like you have to go for relatively better, I mean, a solution or the design for different aspects. Will come into that. What are the reasons why you need for the good or bad design? Okay, so basically, then what is the good or bad design? Will come into that. Okay, as I mentioned, there is no single way, unique way that a problem can be solved by a single solution. I mean, it have more than one such solutions is possible. Okay, so and accordingly, the design solutions also come. Now we have to understand which one is good or which one is a bad design. Okay, so now what is good software design is, first thing, it should implement all the functionalities. It should not miss whatever it is there in the SRS document. Okay, it should not miss any particular functionalities. Okay, any functionality, if it is mentioned somewhere in SRS document, it should not miss. So in that way, its basis should be complete. Okay, it should be complete and correct. It should implement, or it should the design should reflect all the functionalities of the system correctly. And most important is understandability of the documentation. It is all throughout, even in the SRS document also. We have discussed understandability. Understandability is very, very important for the next phases, because if you do not understand these things now, how do you say which is understandable or not? If you can remember correctly, in the last, I mean, during SRS, we have mentioned that uniformity in defining any particular term in the documentation. Say a particular variable x, you are defining in one place as an x, another place you are defining as a. Though they both are the same variable. Now, if you do these things, it will be very, very difficult to understand. What you mean to say, because if you're mentioning x and if you're mentioning again another place as an x, then there is no confusion, because you know that x is already being used. But if you vary because of some poor documentation or design, possibly you may refer the same thing in two different names and all. So in that case, it will create a lot of confusions, and if that confusion persists, it will propagate to the coding team, it will propagate to the maintenance team also, because you know maintenance is the most consumable phase in software development. Okay, so it should be understandable. Okay, it should be easily understandable from there, and it is efficient in the sense that how good you are basically representing all the facts, or how you are basically represent all the functionalities in a proper way. That you can say it's more efficient, and I'll show you some example. And then another factor is like how easily you can edit, delete. See, in case of I mean, in normal other design, if you draw everything in a pen and paper or in a pencil, then it is very easy to clean it up using in eraser and all. Okay, so if there is any error that propagates to actual implementation while construction is almost done, then it's very, very difficult to correct that error. Okay, correct that error. It's not like a pencil or pen that you will erase through eraser and you can correct it. So if that there is a flaws in the design, it will going to be propagated in the actual implementation, and once it is in actual implementation, it will going to create a lot of issues. Okay, so the fact here is that the design should be something like that is easily changeable. You can correct, rectify at any moment of time, because rectification means since all the modules are related with some way each other. Now, if you correct in one module, if you remove one module, there are so many other modules also going to get affected from there. So my design should be something like that, such that if I remove a design, if I remove a module, it will going to give a very less impact to the other dependent modules. So though in reality it may be very unrealistic, it may not possible to do that thing, but that is going to be the target, like it should be easily changeable. Okay, easily changeable. I have, as I mentioned, understandability of a design or even any documentation is very, very major issue, because that determines how good my design is. If my design is not understandable well by some of the other team, then we'll say that the design having very poor understandability. Okay, and that's why it's easy to maintain and easy to change, as I've discussed. That is also I have mentioned that if your design is not well understandable, then the maintenance team will going to face a lot of difficulties to understand what actually the design is and what the error happening or what are the changes that need to be done during the upgradation of that software. Okay, so accordingly the maintenance cost will going to increase. Okay, because you have to put lot of time to understand the design itself, then only they can go for correcting some module, like if there is any error or some customer asking for some upgradation of that particular functionalities. So until unless you understand well what is the design is, it will be very, very difficult to correct or do some any changes during maintenance phase. So you can see that understandability is so important for all the teams. So as I mentioned, like it should be consistent all throughout, like other SRS document or other documentations. Okay, because whatever name you are giving, it should you have to avoid very cryptic name. Okay, normally whenever you give some name for any functions, any data structure, any variables, in that case it should reflect the purpose of that particular functions or variable. Okay, it should not be like x, a, b. It's meaningless. It is very difficult to understand. So you have to give the name, maybe large big name, but it will reflect what is the purpose of that as far as possible, as far as possible. Okay, and modularity, you have to be very cleanly decomposed. Now, what is cleanly decomposed? Cleanly means, neatly arranged means, whenever your design is very neatly or cleanly decomposed, and if you draw the modular structure or structure chart, it will some way going to give a tree-like diagram. Whatever we have discussed like previously, that M1, M2, M3, and M4, the way you have arranged, it will going to give certain kind of layering or level structure, hierarchy or tree-like diagram. Okay. So, so modularity is it's very important in case of modular model design. Okay, so if you are well planned, if your design is very clean, neat and clean, then you're going to have a very neat and clean modular structure in the form of a tree. Okay, and modules are somewhere very independent of each other as far as possible. Though it's not in real life, it's not possible that you can have a independent modules, no dependency with the other modules. It's not possible, but less dependency with the other modules is the most expected thing. Okay, less dependency. That means it should not depend much about the other this things, I mean, modules too much. Okay, and if, I don't know whether you have studied or come across that term called divide and conquer principle. Um, I mean that normally if you have gone through the algorithm course, then there is something called divide and conquer. Divide and conquer means whenever you have a very big problem, you cannot go for solving the whole problem in a single shot. The best way is that divide the problem into sub problems and then try to solve those small problems in isolations. Then actually you are going to get the solution to the actual big problem. So that is the main idea behind the modularity. Take a large problem called library automation system, divide it into some parts, and then again those parts can be subdivided, and then again those parts can be subdivided. You can go on. You can go on as per your own decision or design plan. Okay? So divide and conquer is the main principle behind modularity. So if your modules are highly independent, means they are not depending on the other modules. Okay, then it's very easy to understand, and then it will reduce the overall complexity to understand the overall design. Okay, because if you have say isolated modules, okay, say this example. Think about this example. One side, left hand side, there is a very neat and clean diagram, and that means they are arranged in a tree structure. And you see in the right hand side, they are they're so poorly designed. Then there is a lot of interactions, dependencies are there among the among all the modules. Okay, so that considered as a very bad design, because they are so much dependent with each other, all the nodes. Then you cannot change. That change in a one module may give a ripple effect with the other dependencies, and that will going to propagate all throughout the design. So this is the most worst kind of dependencies. But you see here, changes in the right hand side, in one of the module, if you change it, either there is no effect in other modules, or if it is there also, it is very minimal effect that will going to give it by the change of one module to the other module. So that's why if you have a tree-like structure, not a graph-like structure, the modular structure or structure chart, then we'll say that these are very clean on good program modulation, or sorry, modular design. And if it is very highly dependent arrows are there from one module to the other, then it's going to be considered as a very bad design. So now how to say? I mean, there is no quantitative, there is no concrete way to say that this is the score of modularity, this is a good design, this is a bad design, the score is this because of that. No, there is no way, straight way, forward way to say that which design is good or which design is bad. So one way that we have done is it's neatly it's like a tree-like structure, hierarchical structure it can give you. Then the module is good. Now, whenever you have these things, there are two factors through which we normally consider that modularity is very good, or that design is very good for a particular problem. It's based on two factors. One is called cohesion, another is called coupling. Okay, there are two concepts. You will see these things. Now, when a modularity is good, when we'll say that the cohesion is very high and coupling is very low. Okay. Now, what is cohesion? What is coupling? We'll come to that. And another element of good design is called low fan out and abstraction. What is low fan out? Low fan out means fan out means an out direction arrow from a particular module to the other module. Okay, other module, that is called fan out. So, whether its example is there or not. Actually, let me tell you. Here in this example, the fan out is for that module is 2. You see, there are two outward degree from this module to the another two module. The for this module, the fan out is how much? 3. Why? Because there are 3 arrows are coming out from that module. So that means this particular module is dependent on this module 1, 2, 3, 4, module 5 and module 6. Okay, so they are dependent on 3 different modules. Okay, 3 different modules. So that is called fan out. Fan out. Okay, what is fan in? Fan in the inward arrow. So for M4, so almost all nodes they are having fan in is 1, because there are only one arrow which is coming to that particular module. So that is called fan in. So almost all having fan in is 1. But here you see, I mean, you need to count how many is there for this particular module, the fan in and fan out. There are 2 fan out. Sorry, there are 3 fan out. That is, this is 1, 2, and 3. And what? How many fan in? 2. Sorry. No, sorry. Fan in means this fan out. I'm talking about fan out, outward one. And fan in is 2. Okay, fan in. And in this example, fan in is 2 and out is 3. So that means if your fan out is 3, that means this particular module is dependent on 4 different modules. Okay, and fan in means, I mean, more fan in means what? Fan in means that is how much time. So how much time a particular module is being used. Okay, and so that is called fan in. Okay, so if a fan in is high, that is encouraging. That is acceptable. If the fan in is high, it means that module is being used and reused by many other modules. That is, reusability of the module is very high if the fan in is number is high. But fan out is high means that one module is dependent on other modules. So that is not a very good design, considered as a design. Okay, so that's why low fan out is encouraged, and abstraction. Okay, that actually creates that abstraction. We have discussed many times about that abstraction, that that you are basically avoid the inner details of that. You are just concentrating on what is called the major part of that instead of how it has been done. So that abstraction is also helpful in the modularity. Now let's come to the cohesion and coupling. Okay, so cohesion is basically a measure that reflect how functions within a module are highly related with each other. Okay, so if a set of functions within a module are highly related with each other, then we'll say the cohesion is very high. Okay, and the dependency between two different modules, okay, or the different modules determines how the coupling is. Okay, the coupling. So more dependency means more coupling. Okay, more dependency means more coupling. So the cohesion is a measure of functional strength of a module. Okay, so a cohesive module performs single task for a function. That means their purpose, though there are five number of functions, there are five number of functions. Say within a module A1 or M4, say, but they are basically dedicated towards performing a single task, single activity. Okay, single activity. Okay, that is called the cohesive module or cohesive module. If you can have, if you can club those functions which are related, highly related with each other, and then they are, if they're performing a same task, their main concentration is always solving the same problem, same task, performing same task, then we'll say these are highly cohesive. And what is the module for coupling between two modules? It's basically the measure of degree of interdependence or interaction between the two modules. Okay, that means how strongly two modules are related with each other. Okay, so that is discouraged. If your coupling is less, that means you have a very less dependency to one module to the other module. And if you have a very high coupling, means failure of one module, dependent module may give a side effect to the other, and it is very difficult to change also. So that's why what's the expectation? High cohesion and low coupling. That is the main I mean, thing. Main when design, any good design should have high cohesion and low coupling. Okay. Okay. So so what it reflects, if a modular structure having high cohesion and low coupling, or a module having high cohesion and low coupling, then you say that it's functionally independent of each other. Say there is one very ideal case. I mean, it's not. It's a very imaginary kind of a case that if module is there which is not at all related with each other. Okay, that means the coupling is zero. Okay, the coupling is zero, and the cohesion is extremely high. Why? Because that module is, since it's not depending on the others, but at the same time that module is performing a particular task. Means the set of functions which are there inside that, they are performing a particular task. In that case, what will happen? They are completely independent. Okay, they are completely independent. Why? Because they are not depending on the other modules. Okay, I mean, even you can remove it very easily, and I mean that do not have any impact on them. But in reality, this is not possible. That module is there which are not connected with the others. Okay, so if the coupling is zero, if the coupling is zero means if there is no dependency, or if it is a function, that means it's a functionally independent. Okay, so naturally it will going to be less interactions with the other modules. That means zero is the extreme case, but the expectation is that it should have a minimal interactions with that. Less number of interactions, more independent if a particular module is. Okay. So why, if it is a functionally independent module, what are the advantages that you're going to get it from there? Better understandability, because you do not have very zigzag arrow and all. So you just have to understand only that module. Okay, okay, fine. This is a module, and it's not taking any help from anyone. So you think about the design diagram that you're going to have a single box. So it's very easy. But once you have a more number of boxes and then you have a zigzag arrows and all, it is very difficult to understand. So that's why the most simplistic case is that a particular box is there in your whole page. So it's very easy to understand. Okay, and naturally it will reduce the complexity because there are no dependency among the other modules. So it's very neat and clean diagram. Okay, and then you can easily understand that, because it's not depending on, say you have a function, you have a module, then it's invoking some other module functions, then that invoking other functions. Now to understand, okay, understand that how that particular module is performing. Say for example, you have something called I mean ID, member ID, and for a renewal process. Say so user has given some member ID. Now member ID means you have to take the help of some other module which will going to search whether that any persons which is there in that database or not. So if that it is available, then it will return the all the details. So that means it is actually depending on some other module. Okay, that searching member details. Okay, it is there somewhere in other module. Searching member details. So that means what? To understand, you have to again go to that module. What actually that particular function is doing? That searching searching member details. Okay, so then you have to go again. Maybe in the search detail, you may have some other dependency with the other thing. So then again, you have to follow the chain, and then you have to go and understand. So these always going to create a kind of a complexity, but you cannot avoid. In true sense, if you cannot avoid, but if you can avoid, then that is the best thing that to understand a particular module and its function. Okay, and of course, if you have a less dependency with the other modules, then error in one place will not going to give a ripple effect to the other dependent modules. Okay, because they are all in isolation. Okay, so and if it is less number of iterations are there with the other modules, so error propagation chances are also going to be less or low. Okay, so if more dependencies are there for a these things, say for example, the example that we have shown, sorry, say for example here in case of this, uh, in case of this particular um, um, in case of this, the error may occur from M4, the error may occur from M5, the error may M4 occur from M6. It's very difficult. It is very difficult. Even the lead diagram is relatively better because you are very straightforward. But you see here this diagram. If there is any error, okay, if there is any error that occur here, it's very difficult if from where it may come that occur. Let us assume that whatever it is there inside that module is perfectly okay. Now some error is occurring. Now that error is occurring from where? Okay, you have to look into, like, this is an area from where the error may come. This is the area from module from where the error may come. This is the module from where it may come. Okay. So now again, these error you have to again check back where from it is coming. So they are all like a chain. Okay, the error propagations you have to look into. If it is a very, I am just showing you with very few number of modules, but think about very large problem and more number of modules are there. Then it will be very difficult to do that thing. Okay, so error propagation, um, um, it will going to be less if it is more independent in nature. Okay, in terms of diagram, and naturally there will be no effect of one module from the other, and of course the reuse of the module is very possible. Say for example, nowadays lot of Python packages are available for any problem. So now we have to since they're very packages and the packages they're stored somewhere. Then you have to assume that those packages are perfect and it's not generating any error because they are highly tested models. That's why we can say that packages is independent. Whatever it is there in that model, they are completely independent. They are not depending on the other kind of thing. Okay. So what will happen? It is then that's why people are using day by day more number of packages. Okay. So, Python you take, Java you take, whatever modern language they are using, reusing. Okay, reusing those models. Why? Because they are independent. It's not like that whenever you are using, you have to take care of some other things also. No, it's not like that. If you use the package, it's self-sufficient. Okay, then that's why the uses of those packages are very high. More. You don't have to think too much about that. You have an abstraction. You know these functions I have to call. You are calling. You are going to get that result, and it's completely error-free. That is the only thing that you have to depend on. Now, we can classify the how cohesiveness that about the cohesiveness. We don't know what is cohesiveness. That functions within a model, how they are dependent with each other. More strongly they are related with each other. More strongly they are performing a same task. We'll say that they are basically highly cohesive. Okay, but as I mentioned, in reality, it is not that the case. Sometimes it varies also. Okay. Now, according to that, what is their degree of cohesiveness, or what is the magnitude of cohesiveness? Based on that, or how the functions are related with each other and all. Accordingly, the cohesiveness can be uh, classified. You have different types of cohesiveness. Okay. So, looking into the type of cohesiveness that it is there, okay, something, then we can say that whether it's highly cohesive or low cohesive. So our expectation is high cohesion. See, these the different types of cohesiveness: coincidental, logical, temporal, procedural, communicational, sequential, and functional. Now, coincidental is the low cohesive structure, and functional is the more highest cohesive structure. So, coincidental is the very worst or bad cohesiveness, and functional is the most perfect cohesiveness. Okay? The better, cohesiveness, the best, I say, best cohesiveness. And then you have a logical, temporal, procedural, communicational, and sequential cohesiveness that you can use it. So, what is that coincidental cohesion? So, the module basically performs a set of tasks. Okay, and the functions which are there, they are very roughly. I mean, if you make a module and you put some functions on, hardly they have any relationship. Hardly they are performing a similar task or single task. Okay, and then you can say it's very bad type of question. That means it's some way it's you are putting it over there. It's coincidental. You can say it's a coincidental. It's very loosely coupled with each other. Okay. So that means, I mean, you have five sub functions. You are making it as a module, and then you are supplying. That is not going to be considered as a very good question, and what we call it is a coincidental question. Somehow you are managing to put it into a single module. Okay. So out of coincidence, you are basically putting one. Say, for example, there is a function called coincident function called uh, some module name we don't know. Some operations are there. We are putting some functions called issue book, create member, compute vendor credit, request library and leave. Okay, they're completely, you can see you cannot say these functions some way are performing is active similar say, single task. that the role of the functions are somewhere targeting to a particular task. No, it's not like that. One is issuing book, another is creating member, another is computer vendor credit, another is request liability. So this is the worst type of question, and what we call it the coincident question. See the best type of question. Okay, best type of question is to see that issue book, return book, query book, find borrower. They are trying to perform only one activity, that is called book lending system, managing the book. Okay, book issue book or return book. So related to the book transactions in the library. Okay, they are highly cohesive because their task or activity is targeting to a particular activity, that is called managing book lending. Okay, so if you can club those functions in a single module, then we're going to say that that particular function is called cohesive function. Up to this, is it okay? Is it clear to you or any doubt? Or you are sleeping at 4 o'clock? Is there any query, doubt? Hello? Any doubt?
No, sir.
No, sir.
So that means you understood everything. Am I right? It is clear to you. Is it clear? I mean, is it clear to you everything? No. Yes or no? Is it clear to you? No answer. Yes or no? Whatever I have discussed, is it clear to you? You are not giving any answer. You should say either yes or no. Any difficulties? Any difficulty? See, this is theoretical, but who says there is nothing called theoretical? Okay, there is nothing called theoretical because this is some way it's practical. It is followed in an industry. Okay, so these concepts directly or indirectly may be helpful if you join some industry. Of course, if you do not join an industry, hardly matters. Okay, hardly matters. So many good designs and everything. This subject has been incorporated, though in the new syllabus, I think I have removed. As far as I can remember, I have removed from your new syllabus, which your juniors are studying, because we have very less scope. But the fact is that in the industry, some way these things are going to be followed. Okay, so directly, indirectly, maybe they are having some their own style of software design and software engineering. But some of the basic things are it will going to be there remain constant. So if you have some basic idea on that, it will help in your future. Anyway. Now, next stage of cohesion is called logical cohesion. This is relatively better than your coincidental cohesion. Coincidental is the host. Okay, that's a logical cohesion. So, some way it's not dependent, but some way they are broadly they are performing similar operations. Okay, they are not dedicated for a particular task, but they are performing a similar type of activities. Say different types of inputting data, different types of outputting data. There are some error handling which are there. So let us assume you have divided, you have so many input functions are there, so many output functions are there. Okay, input output function means that through that function you want to read some data input from the user and to do some output from there, some functions which will be dedicated for output. There will be n number of such input functions and output functions, and there will be n number of error handlers. So what do we have thought of? Instead of putting in different models, your design is not very good, but since you have identified this thing, you let us assume you have thought of the I'm going to make a module for input. Okay, so all the input functions are going to be there inside that. I am going to club all the output functions. There are n number of output functions I have designed. Say output, outputting a student record. Say outputting a book details. Say outputting members fine. Say outputting the list of books which are available. So lot of output functions will going to be there. So what I can do, I can club all together as an output function module that will going to just performing one task, that output task. But see, the outputs, all outputs having all different purpose. Okay, all different purpose. But some, since they are doing similar activities like similar operations, that's why we are clubbing. So that will make some sense to put all together what we call it as a logical question. Okay, so a set of print functions to generate output report and into a single model. Okay, all set of functions, print functions that I can do from there. I can club it together. So that is relatively better, because they are not random collection of functions. In case of coincidental, it's a purely random collection of functions. There is no valid reason why I am putting it all together. Logical question having a relatively, you have some justification. Okay, fine. I have a module that clubs all the functions related to the print activities. So, some sense, but it's not a good question. That means if you think about that function or module, there are so many other activities which is going on. Every time they need to be highly dependent on that particular module called print module. So they are highly dependent on that. Okay. So lot of things depending on into that particular module. So that reduces the independence. Now temporal cohesion. What is the temporal cohesion is? That means a set of functions which are there, which temporal means based on time. Okay, temporal means based on time. So if your task is something like that, that they need to be executed at the same time. Okay, so no purpose may be different, but they need at the same time to be executed. Say operating in an operating system, there are some independent services which are there. When you are booting your machine, they are performing different activities. Say loading the memory, you are uploading the operating system on the memory, keeping all the previous state nowadays in Windows 11 and all. That whatever we have stored last open it up, it remains over like that only. So what happened? That needs to be executed during the starting of your computer. Okay, so that means all the activities, tasks, activities, functions need to be executed on the same time. Say initialization of your machine. Okay, startup, shutdown. Okay, some processes and all. So I mean, in Windows operating system, so many services are up, remain up during booting itself. Okay, so that you can club it together as a module, and though they are not performing the same task, their activity is not same task, but somewhere they are related with each other. Only one justification that all the functions are going to should be executed based on, I mean, at the same time. Okay, so that type of cohesions are basically called temporal cohesion. Okay, that means they are dependent with each other only on the time. That means they need to be executed at the same time. Now, next type of cohesion is procedural cohesion. So it's basically a set of functions which are basically part of a single algorithm. Okay, I'll show you some example. Part of a single algorithm and certain sequence of states that have to be carried out in a particular order. Okay, in a particular order to fulfill the requirement and all. So is there any something? Yes. Say procedural question. You can say that there is something called order processing module. Okay. So what you have to do that you have to have some functions called login. You have to do it in the say there is some trading or online system, say Amazon or Flipkart. Okay, so there are some functions which are you can club it together. Say you need a login. Okay, you may have logout. You may go for place order. You may check for the order. You may print the invoice. Okay, um, and other things are not directly related. But say for example, Amazon or Flipkart, you have these activities like you have to log in. You can place an order. You can check what is there in the order. You can check what is there in your file. You can check what is there in your So lot of issues here. Switching for power. It's going morning, evening. There is a power cut going on. Very difficult. Okay. So is my screen visible?
Yes, sir.
So procedural means a set of functions which are having their independent activities like Amazon and Flipkart. Then different things are there, and then it's up to your choice which you are going to use it. Okay, it's not like that. They are highly dependent on each other. Login is fine, that is something, but check your order and place your order. It's not dependent. Like you need to have a place order, then only can you can check order. You can go independently to the check order, and you can go independently to place an order. Okay, you can go independently print invoice or bill. So that it's not necessary that you have to place an order. But what they're having, they're having a set of task that they basically part of that. Even for a large algorithm, if you are implementing, you can club it all together, and they have different activities, tasks, which you can call, invoke as per your choice. Okay, it's not mandatory to call them all, but some it's more better than the others. Then another one is communicational question. Okay, here what happens? Here all the functions are trying to update the same data structure. Okay, same data structure. Okay, say for a stack. Okay, you have a stack in an array, then push and pop. Okay, they are actually trying to change that same data structure that is called stack. Okay, or that same array. So that what we call it as a communicational um, equation. That means if the functions which are there in a module are trying to update a particular single data structure or single data, then we call it as a communication question. This I think I have done something wrong. It's not sequential question. It's basically communication question. What actually happens here? You see, there is something called student record. It is a array, okay, that or a record, okay, record, you know, structure. Using some C, you have a structure, you have student name, marks, grade, everything is there in that inside that structure. Now you have some functions that admit student, enter marks, print grade sheet. Everything is dependent on student record. Okay, once you have student record, you cannot do admit student, you cannot do enter marks, you cannot do print grade sheet. So they are all dependent on that structure called student record. So that's why this is all called communicational quotient, because they are trying to upgrade or access the same data structure. All the functions are somewhere related to the same data structure. So that kind of questions are called communicational question. It's not a sequential question. Okay, it's a communication question. It's a mistake. Now, what is sequential? As the name suggests, functions are arranged in such way that it will going to complete a task. You have to execute those things one after another. Okay, one after another. Okay, say binary search. Okay, say binary search. What are those functions? You have a function called sort, you have called sort, and then you have to display that. Now you cannot directly go to display. You cannot directly go to search. Okay. First you have to call sort. Okay. And then you have to go for search, and then you have to go for display. Okay. So that way this sequence actually follows among the functions. Similarly, another sequential question is something like that. One another example that I can tell you, like say during booting. Okay, you're booting your operating system. There are some functions which need to be executed one after. I'm not talking about the services, I'm talking about the booting process. There are series of functions which need to be executed one after another. Okay, one after another. So that what we call it as a sequential, that booting module. If you say it's a booting is a module, then the functions which are there inside that module, they are sequentially cohesive, because they need to be executed one after another. Okay, that the first is wake up, then loading operating system, then cleaning the RAM. So many things. That's with I mean, whatever it is there, you have to execute sequentially. Similarly, if you have a kind of a module like create order, check item availability, place order, um, on place on some place order on vendors. It's a single function function place order on vendor. Say for a particular Amazon or Flipkart. So you have to create an order. Now while creating an order, you have to check it whether that item is available or not. Okay, if it is available, then you're going to place that order. You cannot directly go to the place order. You cannot directly go for the check order availability, because until unless there is a requirement. So once people go for it, creating an order, like I am going to place an order, then only you are going to check for that availability. Or somewhere around also that can be done. Normally you can show that this particular item is not available. Okay, then you cannot place an order. But until unless if that item is not available, you cannot do any order placing from there. So that way, these kind of dependent functions within a module are called, if it is there, then it is called sequential cohesion. Okay. And the last one is what we call it as a functional cohesion. Okay. So what it is there? This is the most tightly strong, tight and strong. I mean, tightly related functions are there in a function, and their purpose is to do a single task. That the target is to do a single task. Okay, then it is called the functional cohesion. Okay, so say employees payroll. Okay, say there is a model called employees payroll. Okay, so what we can do, such kind of, when we say this is cohesion, it's a functional cohesion. If we can describe the function using a single sentence, what is the function? What is the purpose of the function? The purpose of the function is to managing employees payroll. That's all. Finish. Single sentence. You can describe that thing. If you can able to do that thing, then you will say it is basically a functionally cohesive. Okay, there are other models, whatever we have discussed, they are also somewhere like that only. We hardly, I mean, there are very minor differences which are there, like communication or sequential and all. But something, this is something they are highly dedicated. They used to call it very highly dedicated, and that you can describe. Say, pay slip for an employee, you have compute. Say, to generate a employees these things, you need compute overtime, compute work hours, compute uh, deductions. Okay, or compute deductions. So one thing that you can easily understand that they are not sequential. If you want, you can separately calculate invoke compute overtime. You can separately compute invoke compute work hours. You can separately calculate the deductions and all from the salary, and then you can generate the payslip. So sequentials are also in some form they are functionally cohesive, but they need to be executed in sequence. But in here you can see the task is only one. That is, they just help in generating the payslips of the employee. Okay, but they not necessary that they have to be executed in a sequential manner. So you can do parallelly. Okay, parallel also do, or in any order you can invoke. It hardly matters for that. So that is what we call it as a functional cohesive model. Now, in terms of text, like the previous one that I have mentioned, sorry, that I have mentioned that when you can describe a function's purpose in a single sentence, then we can say this is functionally cohesive. So similarly, how we can determine the cohesiveness? Looking into the purpose of that module. Okay, if your if the sentence that you are writing for a module, okay, it's a compound. Compound means you have, say, this module is performing print and calculate print and uh, generate the ID. That means and, that is compound sentence. Okay, that means if you have a sentence that you need to describe the purpose of that function or a module, sorry, module, you need compounds like and all you are joining. Then these are basically called communicational cohesion. Okay, communicational cohesion. And if the words like it first do this, then next it do this, then after that it's doing this thing, then it is basically called sequential or temporal cohesion also you can say that. But if that words like initialize, okay, if it is there, then this is more about temporal cohesion. But sequential or temporal, is sequential means until and unless one is completed, you cannot start the other one. But in case of temporal, they need to be executed all at the same time. Okay, they may go parallel, no problem. They parallel. A sequence hardly matters, but they need to be done in the starting of the machine. So that is the time, the starting of the machine or during shutdown of a machine. Okay, so that is temporal. Okay, so but it hardly matters whether there is a sequential or not. Now I'll just start coupling and today I'll end that thing. Tomorrow I'll again going to take that same time class on reviewing part of the design. So what is the coupling? As I mentioned, how closely two modules are dependent with each other. Okay, dependent with each other. Dependency, I already have mentioned that to complete a task, you need to invoke or take the help of another module. That is called the dependency. Okay, and if the more dependencies are there with the different modules, that is more complex that module is. That means your design is not very good. If you have something like that, then your design is not very good. Okay. So there are no ways to precisely determine the coupling between two modules. It's very difficult. So we'll see five different types of coupling which are exist between two different modules. So we're going to see these are the five different modules: data, stem, control, common, and content. Okay. This we're going to see in the next class, the different types of coupling. So the degree of coupling is basically very high as you go from data to the content. Okay, that means high coupling is very bad and low coupling is considered as good. Okay. At the same time, high cohesion is considered good, low cohesion considered is bad. So that these things you just keep in your mind. So in the next class we will study the different types of coupling and all. Okay. So if you have any, do you have any queries? Do you have any queries? Do you have any query?
No, sir.
Okay, fine. See you tomorrow.